Hello and welcome back to Connor's Chemistry. What we do is have a look at another exam question, still from a specimen paper from the chemistry that AQA released. This is question 3, and it says elements are made up of atoms, which is quite a nice easy statement because we should know that already. The first question says, what is the approximate radius of an atom? And I'm afraid this is probably just one of those numbers you're going to have to just try and remember. Okay, and the answer is 1 times 10 to the minus 10 metres. Okay, sometimes in the exam there's just facts and numbers you just need to remember, and the radius of an atom is one of them. Okay, so let's get into a little bit more of the challenging questions. So figure 4 shows the atoms of 5 elements. So we've got R, S, T, U and V, and as you notice they've not been given their correct symbols, they've just been given 5 letters from the alphabet, and it makes that statement there. Letters are not the symbols of these elements. Complete the sentence. All the elements in figure 3 are in the group something of the periodic table. Okay, and this is where we need to kind of work it out. So if we think this bottom number, remember, tells us how many protons there are in that element. The top number tells us protons and neutrons. Because it says they are atoms, okay, told us that there, then I know the bottom number is the proton number, and it's going to equal the number of electrons. So as we know our rules, this is going to have 2, 1, so those 3 electrons, 2 in the first shell, 1 in the second. This is going to have 2 and 1. Then got 11, which would be 2, 8 and 1. Then got 19, it will be 2, 8, 8 and 1. And I think we can probably make a little prediction. This might be 2, 8, 8, do my maths now, 8 a few ones, but it will have 1 at the end. Okay, so all of these have 1 at the end, and that tells us the group number. So this should be a nice easy question, and the answer is group 1. Okay, apologies for getting this one wrong. Next question then says, which 2 atoms in figure 14 are isotopes of the same element? Now, the first thing we need to do is probably identify and define the term isotope. Now isotopes have the same number, get me words my George, of protons, but different neutrons. Okay, so let's look back at the question. So we're looking for 2 atoms that are isotopes. Okay, so let's turn back to our question. So we are looking for 2 that have the same number of protons. So we're looking for 2 that have the same number at the bottom. And quite easily must be these 2, because they're the only 2 with the same number of protons at the bottom. So 1 mark, we would write R and S. That would get us 1 mark. And we now need to say exactly why we think that. Now, because we've already annotated our question, these 2 statements here are actually our answers. So we get 1 mark for saying same number of protons. That's our second mark. And our third is but different numbers of neutrons. And this is a sort of question that can come up quite regularly in the exam, and they're expecting you to be able to know that. Last question. Now this is a 6-mark question, so we're at least going to have to make 6 separate little points here. The halogens are in group 7 in the periodic table. Brilliant, so it's told us what group they are, so we can always check our periodic table if we need to. Explain the trend in reactivity of the halogens. So trends are just the patterns. Okay, so things they have in common, things are, well, patterns they have really. So we're going to look at things the exam would want us to write. Now because they're in group 7, we know they have 7 electrons in outer shell. That's what our group number tells us. We know because they've got 8, they will want to gain an electron, so just 1. Alright, they all then, because they want to gain an electron, all form ions with a -1 charge. That's something that is the pattern of them. As you go down the group, they get less reactive. Okay, and obviously you could write these into sentences, but actually these probably would be okay to gain you many marks. And obviously further down the group, they have more shells. Because obviously they're getting bigger. And remember, those periods tell us how many shells there are. this is just the simple statements and descriptions that we could make. We could then have a look at why it does some of these things. Okay, so we could say the reason why it wants to gain an electron to be like a noble gas, because obviously they have full outer shells, and most elements when they react want to be having a nice stable full outer shell. They are less reactive because they have more shells. Okay, there are more shells, more energy levels, so actually that's the reason why they're less reactive. Okay, the reason they've got more shells means the nucleus is shielded. Okay, and this is quite a usual thing that asks for an exam. It's just all those shells, and I've got my I and the E around the wrong way, and I did it again. That means nucleus is shielded. Okay, so against any of those electrons. Okay, so lots of these things, there's probably 2 or 3 other things you could write, but in terms of this question, you could just write 7 electrons in outer shell. They gain an electron to be like a noble gas. They form ions with a -1 charge. As you go down the group, they're less reactive. As also when you go down the group, there's more shells, and that more shells means the nucleus is shielded, so there's less attractive force from those electrons, and we'll add that in. So less attractive force from incoming electrons, we will say. Okay, and that would get you 6 marks. So on that sort of question about the halogens, about those different atoms and isotopes, it's a nice question to gain a lot of marks.